So let's now look at another example of how to use the chain rule. So let's recall that the chain rule can be expressed in the following way, or it can be expressed as saying that df du times, well, you can write du dx here or dg dx. It's the same thing, where here we're putting u as the variable of f, and we're understanding that this is supposed to be replaced by g of x. Okay, so let's now use it. And let's use it to compute the derivative of sine of the square root of 1 plus x to the third. And let me now move this to the side so I have a bit more space. And one of the main points that I want to get across when doing this example is that please, if you can, differentiate in baby steps. It's so easy to make mistakes when you're differentiating. So if you can, break your computation down into small steps. So when you're using the chain rule and you're using it in you can say on multiple levels, what we should do now here first is say, okay, what's our outer function and what's our inner function? So this thing here now would be my outer function, and this thing here would be my inner function, okay? And whatever is my inner function, I'll give it the label u. So here u is 1 plus x to the third. So this means I'm now differentiating with respect to x, the function sine u. And here, I can, it's perhaps better to have du here now. And here, if I'm applying the chain rule, I'm supposed now to differentiate the outer function as if u was the variable. This will give me cosine u. And then I'm supposed to differentiate the inner function u, or g if you want, as if x was the variable. So here I'm getting now du dx. And now let's not try to differentiate this inner function here in one go. Let's just write out what we have. So cosine u, let's just keep the u so I don't have to write too much. You can just replace it by this thing here whenever we feel like it. And then now I have d dx, and then the square root of 1 plus x to the third. So now I have this guy, I know who he is, but I need to differentiate this guy here. So what do? Well, we already used u, so let's put another label as this guy. Let's do v. So let's put v is equal to 1 plus x to the third. This allows me to view this thing here as the inner function and the square root as the outer function. I'm getting here now cosine u, and then the derivative of the square root as if all of this was just one variable. So let me write that out. So d dv square root of v times d dx of whatever v is. And now what is this guy? Was 1 over 2 square root v. And now it's just the derivative of whatever v is. So let's plug in v here, 1 plus x to the third. I mean, you can skip some of these steps if you feel that it's getting silly. But now, my point is that I can be quite sure that this thing here now is the correct answer. Because I can really see the flow. So the outer function here was differentiated, became this guy. Then I had this problem here. Here the outer function is him, so he's differentiated, he becomes this guy. Then I keep the inner guy here, and he's differentiated, and he becomes that guy. And in the end, I plug in for u, which would here be square root of 1 plus x to the third. I plug in for v, which would be 1 plus x to the third. And then I have my guy here. And that's my final answer.